Alkyne nomenclature is very similar to alkene nomenclature. Just as in all of the other molecules that we named, the first step is to identify the parent chain, which is the longest chain. So let's count the carbon atoms. 1, 2, 3, 4, 5. So this is pent. The next step is to list the substituents. There are two substituents. We have a fluoro group here, and there's an alkyne over here on the left side of the molecule, which means the pent will have the suffix "-ine" at the end. So this is pentyne. The next step is to number the parent chain. In the case of triple bonds or alkynes, the triple bond will get the lowest number. This will supersede a double bond getting the lowest number. So if you have a double bond and a triple bond, you would number the triple bond first. So if the site of the triple bond is the lowest number, then that means this carbon on the left is carbon 1, 2, 3, 4, 5. So this is 1 pentyne. And then this would make the fluoro group a 3 fluoro group. So this is 3 fluoro, 1 pentyne. Lastly, we need to add the stereochemistry of the fluorine. In this case, it is going to be fluorine's number 1. The alkyne will be number 2, 3, which is counterclockwise, so that will be S. So this is S, 3 fluoro, 1 pentyne. Moving on, let's try another example. Again, we have to identify the parent chain, the longest chain first. 1, 2, 3, 4, 5, 6, 7, 8. This is going to be an oct base. List the substituents. We have an alkene here, we have a chloro group here, and we have an ine here. The next step is to number the parent chain. In this case, we have both an alkene and an alkyne. The alkyne has the highest priority. So this is 1, 2, 3, 4, 5, 6, 7, 8. So now when we work on our name, we have to put them together alphabetically, but ine is the base here. Octyne is our root. So in this case, we're going to put the ene and then the ine. So we will name this oct 6 ene 1 ine, because the alkyne appears at the 1 carbon. We'll put the 5 chloro here at the beginning, and then we can assign the stereochemistry as well. So the stereochemistry here, this is going to be number 1, 2, because this will branch first because of the double bond. 3, we're going clockwise, but this is backwards, so this will be S as well. So we have 5S stereochemistry. The other thing that we need to note is that we have got this alkene here, which also has stereochemistry. This is going to be a Z isomer because they're on the same side. So this is 6Z. So when we include these on the front, it will be 5S, 6Z, 5 chloro, oct 6 ene, 1 ine.